Okay, so the first one is equations of quadratic type. What an equation of quadratic type means is that one variable power is exactly double the other variable power. So here when you look at this, x to the fourth is x squared doubled, or the power of x doubled. Okay? And if you get a problem that's written in quadratic type, what you can use to solve it is called U substitution. And now, we saw a problem like this earlier, but it was set equal to 0, where you could solve it by factoring out the common x squared. Okay, but now, because if you move everything to one side, so that's your first rule, right? Move everything to one side, since you have multiple variables. Okay, this is no longer one that we can remove a common factor. Okay, so if we let u be the whole lesser power, so if we let u be x squared, then that means that u squared would be x squared squared, or x to the fourth. And by using u substitution in this way, we can now rewrite that equation here as 3u squared, because u squared is equivalent to x to the fourth, minus 2u, because u is equivalent to x squared, minus 1 is equal to 0. And then you can solve the resulting equation, okay, for u. So if you set this one up, again, we have prime numbers as our leading coefficient and constant. So trial and error is probably going to be the best way to approach this. So all we really need to test is plus 1 and minus 1, or minus 1 plus 1, see which of these works. So here when I try to find when I reverse FOIL and find my outer and inner sum, I have negative 3u plus 1u gives me my minus 2u. So that is going to be my solution. And I can set each of these equal to, or solve using the zero product rule. So here I get u is equal to 1, and here I get u is equal to, again, when you have a leading coefficient other than 1, you take the opposite of your constant, divide by your leading coefficient. So those are my two values for u. If you are using u substitution, your problem doesn't end here. Once you solve for u, you then have to plug it back in. X squared is equivalent to minus 1/3, and x squared is equal to 1. So you have to plug it in and solve here. So when you do, this is the easier one. I'll extract my square root, take into consideration the positive and negative root of 1, which is 1. And here when I extract my square root, notice there's no real solutions here. So depending on how they word the problem, okay, my only real solutions are plus and minus 1. But if it includes complex solutions, okay, which this set of problems will, you also need to go ahead and solve. So if I extract my square root here, I get the square root of 1/3 I. I take out the square root of negative 1 as an I. And now I'm going to, again, plus or minus. And I'm going to rationalize this. If I take the square root of 1 over the square root of 3, the square root of 1 is 1. Rationalize my denominator, I get plus or minus the square root of 3 over 3i. So I wind up with 4 solutions here, 2 imaginary numbers and 2 real numbers. Okay, I want you to try this problem here on your own. See if you can solve this using u substitution. You get the same relationship. Your highest power is double your lower power, so you can use u substitution. Let u be that lower power, so that gives me u squared minus 8u minus 9 equals 0. And I can solve this by factoring u minus 9, u plus 1. So my u is either going to equal 9 or negative 1. And my u is x squared. So x squared equals 9, or x squared equals negative 1. Extract my square root. Give me x is equal to plus or minus root 9, or 3. And here, extract my square root, gives me x is equal to plus or minus I. And so I have my 4 solutions for that problem. Okay, so u substitution can be used not just for quadratic types that have the single variable. They can also be used for quadratic types that are in sort of different forms that you might not think about. Okay? So if I just gave you this question right here without prefacing that we're working with quadratic types, more than likely, most of you would expand your binomial square, distribute the -6, combine all your like terms, and try to factor the resulting equation. Okay, that's probably going to be what you would look to do. But if you can recognize that this power of 2 is double this unwritten power of 1, this is of quadratic type. Okay, so you can use u substitution here to let u equal the whole binomial x plus 2. If that's the case, then u squared is x plus 2 squared. And it allows you to rewrite this as u squared minus 6u plus 9 equals 0. And then you can solve the resulting equation. Okay, the two factors of positive 9 whose sum is -6 is -3 and -3. So you get your u value to equal 3, and if you substitute that back in, x plus 2 is equal to your 3. Solve, you get x is equal to 1. And again, a really quick and easy solution to your problem, rather than having to go through, expand it, combine like terms, and so on. So here, if you recognize quadratic type, highest power is double that of the lesser. We can substitute in the u's and then solve the resulting equation. We have multiple variables, so move every term to one side. So subtract 21 from both sides, and then look to factor the two factors of -21 whose sum is -4, -7 plus 3. So I get u is equal to 7 and u is equal to -3. So I can come here, replace my u with a x minus 5 is equal to 7, and x minus 5 is equal to -3. Solve each resulting equation, add 5 to both sides, add 5 to both sides, and I get my two possible solutions here for this problem. Okay. So the next type of equation here, again, might be ones where you have what are called quadratic type. Again, we'll go through that in class on Monday. But once again, you're solving an equation, so your calculator is powerful enough to manage that. So we can enter our equations, leave it as it is. You don't have to expand anything out. It should look exactly like what your original equation looks like. Comma x tells it to solve for x. And when you solve, you see here, you get the solution 1.